You know, we're always taught that the goal is to get things right on the very first try. But what if that's completely backward? Today, we're going to dig into a surprising truth, that real, meaningful progress doesn't start with perfection. Nope, it starts with having the courage to get it wrong.
And this quote right here, it just completely reframes the whole process. In engineering, a failure isn't some big red stop sign. It's more like a compass. It doesn't tell you you've lost. It points you exactly where you need to go next to make things better. It really is the beginning, not the end.
So, how do you start? Where do you even begin? Well, you start by making your ideas real. You got to bring them out of your head and into the world with what we can call a first clumsy draft.
And that first draft, it's got a name. A prototype. Now, don't let that technical word scare you off. A prototype is just that, a first attempt. It doesn't have to be perfect, it doesn't have to be pretty, its only job is to exist, so you can finally start learning from it.
Okay, so once you have that first draft, this is where things get really interesting. There's a total mindset shift. Your goal is not to prove how perfect your idea is, no way. Your goal is to find out everywhere it's broken. You are actively, deliberately searching for its flaws.
But why? I mean, why would you go on this deliberate hunt for problems? Why is putting your own creation through its paces so absolutely critical?
Well, it's because an idea in your head, it's always perfect, right? But an idea out in the real world, not so much. Testing is where your beautiful, perfect plan smacks right into reality. It's how you find that fatal flaw you never could have predicted, and you fix it while the stakes are still super low.
And this testing, it's not just random poking and prodding. It's a targeted investigation. You're asking some really critical questions. First up, function. Does it actually do the thing it's supposed to do? Usability. Is it intuitive and easy to figure out, or is it just a confusing mess? Durability. Is it going to survive being used by a real person? And crucially, safety. Could this brilliant idea of yours accidentally hurt somebody? These questions, they turn vague problems into a concrete checklist for what to fix.
And everything you learn from asking these questions, every crack, every point of confusion, every single failure, is feedback. And this right here, this is so important. Feedback is not a personal attack. It's not criticism. It's precious, invaluable data that gives you a precise roadmap for what you need to improve.
So, all of this leads us to the real engine that drives everything forward. It's this incredibly powerful, cyclical process that turns all that feedback into real, tangible progress.
And that engine is called iteration. It's such a simple but honestly a profound idea. You try something, you learn from it, and you try again. Only this time, you're a little bit smarter. This isn't just some fancy term. This continuous cycle is the secret sauce for improving almost anything you can think of.
So let's break that loop down, okay? Think of it like a simple four-step dance. Step 1, you build that first clumsy draft. Step 2, you test it relentlessly to find all the flaws. Step 3, you gather all of that precious data, that feedback. And step 4, you use that data to improve the design. And then, and this is the key, you repeat the whole loop. Again and again and again.
Now, I know this might sound a little bit like a textbook concept, but this exact loop, it's responsible for some of the most mind-blowing technologies that we rely on every single day.
Just think about the airplane for a second. The very first flight was a fragile 12-second hop. So what happened between that and a modern jetliner? Decades of iteration. Engineers built, they tested, and yep, they crashed. But every single one of those tragic crashes provided priceless data. Feedback on wing design, on material stress, on engine failure. Each new model was literally built on the lessons learned from the last failure. The incredibly safe jets we fly in today exist because of a century of learning from getting it wrong.
So this shows us that there are two totally different ways to approach a problem. You can aim for perfection right out of the gate, which, let's be honest, usually leads to fear and getting stuck before you even start. Or you can aim for progress, accepting that your first version is not going to be perfect. And that second path, that's the one that leads to real evolution and amazing breakthroughs.
All right, so let's bring this whole powerful idea down from 30,000 feet and put it right in your hands. Because, you see, this isn't just about airplanes.
I mean, this same iterative process is happening literally everywhere, at every single scale. Whether it's a middle schooler just trying to get a simple machine to lift a book, or a team designing a better water filter for their community, the principle is exactly the same. The path to a working solution isn't one giant leap, it's a series of small, smart, informed steps.
And that right there, that is the most important thing to take away from this.
This iterative loop isn't some secret technique that's only for engineers and fancy labs. It's a mindset. It's a practical, powerful way of thinking that anyone, and I mean anyone, can use to tackle any challenge they face, big or small.
So, I'll leave you with one final thought. Look around your world, at work, in your community, in your own life. What problem do you see that's just waiting for someone to be brave enough to build its very first imperfect, clumsy draft?